So the first thing we're going to do to graph this is to find the horizontal asymptote, which when the degree on top and bottom are the same, that means that we take the coefficients 2 over 1, so y equals 2 is the equation of our horizontal asymptote. So I'm going to graph that in, y equals 2 passes through the y-axis, 2, there it is. Next, to find the vertical asymptotes, we're going to factor both the top and the bottom. And the top factor, you can factor a 2 out. You get 2 times x squared minus 2x plus 1, which will factor. And the x squared minus 9 is a difference of squares, x minus 3 times x plus 3. So the top is going to factor 2 times x minus 1 times another x minus 1 over x minus 3, x plus 3. And if you want, you could write the top as 2 times x minus 1 quantity squared. Now, when we're finding the vertical asymptotes, since you don't have any common factors on top and bottom, you don't have any removable discontinuities, so both of your vertical asymptotes will occur where you're dividing by 0 at x equals 3 and x equals negative 3. So vertical asymptotes, x equals 3 and x equals negative 3. So we'll graph those in, negative 3 and positive 3. So that gives us our asymptotes, and if you understand asymptotic behavior, you know the graph is going to do something like that, or like that, maybe some kind of U-shape in between here, maybe some kind of x cubed shape, or something in here and here. So now we have to do our restricted regions to see what is going to happen. So I already have the factors here. The 2 is always positive. You could put it in your sign analysis table, but you don't need to. The x minus 1 quantity squared, I said either put both of them in or neither in, because that's always positive. I'm just going to leave that out. So the only things that affect the sign of your y value are these 2 factors in the denominator. So x minus 3 is one factor, x plus 3 is the other factor, and together they're going to determine the sign of this y function here. So x minus 3 is going to change sign at positive 3, and x plus 3 is going to change sign at negative 3. So we put those 2 numbers on the borders here of our number line. And so remember that when this is a number line, these are x values going along this way. When x is bigger than 3, for example 5, if you plug in that 5 in here, 5 minus 3 is a positive. So on the interval, when x is bigger than 3, the y value is positive. Any x value between negative 3 and 3, for example, 0, plug a 0 in there, 0 minus 3, that's going to be negative. That's true for all values of x between negative 3 and 3. Any value of x to the left of negative 3, like negative 10 minus 3, that's going to give you a negative. So you know the sign of this term on the x intervals here. This factor here, x plus 3, changes sign at negative 3. Any number to the right of negative 3 is going to give you a positive when you plug it in. Any number to the left of negative 3 will give you a negative. So when both of these in the denominator here are positive, and the numerator is always positive, your y value will be positive, and then negative, and then positive. So these tell you the sign of the y value on these intervals for x. So when x is bigger than 3, the y value is positive. When x is bigger than 3, the y value is positive, must be traveling up here. That means you can restrict this region out. Your graph cannot travel below the x-axis when x is bigger than 3. For values of x between negative 3 and 3, right here, the y value is negative. So the y is traveling somewhere down here, so that means you can restrict out all of this here. The graph cannot travel in this region of the graph. And then when when x is less than negative 3, the y value is positive. So for x values less than negative 3, the y value is traveling up here. And so your graph cannot travel below the x-axis in this region here. So those are restricted. Now, the graph is going to do something like this. It could actually pass through the horizontal asymptote and come back up from below. So to determine whether that happens or not, you are going to do the second sign analysis on a long division. So you're going to long divide the bottom into the top, and then do a second sign analysis on the remainder. So here's your long division. We're going to divide the bottom, x squared minus 9. I'm going to write in all powers of x, so x squared plus 0x minus 9, divided into 2x squared minus 4x plus 2. So x squared goes into 2x squared 2 times. Multiply 2x squared plus 0x minus 18. Subtract 2x squared minus 2x squared 0, negative 4 minus 0, negative 4, and 2 minus a negative 18 plus 20. The x squared doesn't go into negative 4x, so that's your remainder, plus negative 4x plus 20 over the divisor x squared minus 9. This is your remainder. You're going to do a second sign analysis on the remainder, and that's going to tell you whether your y value is bigger than 2 or less than 2. Because this is the exact same thing as your original function. Y is equal to 2 plus this negative 4x plus 20 over x squared minus 9. If you plug an x value and this thing's positive, then your y value is going to be bigger than 2. It means it's going to be above the asymptote. If this value is negative, then you'll get a y value that's equal to 2 plus a negative, which means your y value, you're going to be below the asymptote somewhere. So we're going to do a second sign analysis on this. That's going to tell us whether to shade above or below the asymptote y equals 2. So the top here is going to factor. I can factor a negative 4 out and get x minus 5. And then the bottom is our x plus 3, x minus 3 again. Now, if I factor like this negative 4 will affect the sign of this remainder. So the negative 4 needs to go in your sign analysis table. It's always negative all the way across. The x minus 5 goes in, and then the x plus 3, and the x minus 3. So this is the remainder here. So you only have 3 places where these are going to change sign, at 5, negative 3, and positive 3. So we need them in order on the number line. Here's negative 3, here's positive 3, and here's positive 5. So now my table is going to look like this, where I said that no matter what, negative 4 is always negative. So negative, 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 negative. The x minus 5 changes sign at 5. If you plug a number bigger than 5 in, it'll be positive here and negative to the left. X plus 3 changes sign at negative 3. It's going to be positive to the right, negative to the left. And x minus 3 will change sign at 3, positive to the right, negative to the left. Remember, it's not always positive to the right, negative to the left. If you had a term like negative x plus 5 or 5 minus x, then it would flip 5. One negative there, got 2, 3, and 4. So remember, what this tells you is whether you're above or below the horizontal asymptote, y equals 2 here. So I can shade above or below that area. When x is bigger than 5, the remainder is negative. So when x is bigger than 5, I'm actually going to need to draw another vertical line in here, because I get a sign change at 5, but it's not an asymptote, so I'm using a different color here. When x is bigger than 5, the remainder is negative, which means I'm below, the graph must be below the asymptote in here. So I'm going to restrict this region up here. So this region, the graph is not traveling up here. So it's somewhere down here. When the x value is between 3 and 5, the remainder is positive. So between 3 and 5, the remainder is positive, which means I'm above the asymptote. So this extra region gets restricted out. I could actually restrict down here too, but I already have that out. Between negative 3 and 3, the remainder is negative, which tells me I'm below the asymptote, which would only restrict like above here. So I already know that it's below there. That doesn't add anything. And then to the left of negative 3, the remainder is positive. So to the left of negative 3, the graph must be up here, which means the graph cannot be down below the asymptote here. So those are all the restricted regions. And once you have all the restricted regions and you understand asymptotic behavior, you should be able to get a fairly accurate graph of what we're looking at. So asymptotic behavior, got a vertical asymptote, the graph has to be approaching the asymptote. Up, going this way, and down, going this way. Horizontal asymptote, as x goes to negative infinity, the graph's going out this way, and as x goes to positive infinity, it has to approach the asymptote here. This is a vertical asymptote, so you have asymptotic behavior coming up here and down here. Remember, this is not an asymptote, so you don't treat it like an asymptote. You don't have the graph coming up here or anything. So now you just have to connect these red pieces here. So on this left-hand side, anytime you have a vertical and horizontal asymptote in an open space like this, pretty much will always have this kind of a shape to it. It might be steeper or less steep. You could plot some points to get a little better graph. Graph in here is going to do some kind of U-shape. You can find the y-intercept very easily by just plugging an x value of 0 here, here, and here. If all that's 0, the y value is negative 2/9, which is not too far from 0, so negative 2/9 about there. So the graph's going to come up, pass through that point, come back down, something like that. And then finally, to connect these, you can pass through this. That's not a problem. It's not a vertical asymptote. So it comes down, passes from unrestricted region to unrestricted region. It's going to come back up and approach the asymptote, get closer and closer and closer as x goes to infinity out this way. And that is your graph.